Good morning, and here we are for our next maths lesson. So last week we were looking at telling the time, and we also started converting between a 12-hour clock and a 24-hour clock. So today we are going to carry on with that learning, and we're going to apply it. And we are going to apply it while we are reading and using timetables. So these are not times tables like 7 times 7, 6 times 6. These are timetables. So have a think, when would you use a timetable? Well, we use timetables every day when we're at school to see what lessons we're doing. You are using them at the moment to work out whether you're doing maths or English and the suggested times that you've got. You may also, normally when we're not in lockdown, you may be going on the bus and you might be using a bus timetable. If you go on the train, you might use a train timetable. Or if you are lucky enough to go on a plane, you might use a plane timetable and look at the different times that the planes fly. So this is a really useful skill again, and it's a really good way of us teaching you how to use timetables, but also it's rewinding and applying our knowledge from last week and telling the time as well. Right, let's get started. Okay, so we're going to start off with a little rewind to get us started. So first things first, whenever you look at a timetable, read all the information that there is for you to read. Otherwise, you're going to be looking at this and you're not going to understand it. So this tells me it's a timetable for non-stop flights. So that's flights that don't stop from Singapore all the way to London. And I probably could have given it a good guess it was about aeroplanes because it's got little aeroplanes on it. So I've got departure column. So that's the time the aircraft leaves. It departs from Singapore. The time it arrives in London. We've got a flight number or code, the type of aircraft, the duration. So the duration is how long it lasts for. And then we've got the frequency, so how much it happens. So when does it happen, which days of the week. So first things first, because we are just rewinding to begin with, I want us to have a look at the departure and arrival times. So I want you to put your finger on the time that is the same as saying 11:15 p.m. Hopefully you are pointing at the departure for the 777 aircraft for the BA16 flight, which says 23:15, which would be the same as 11:15 p.m. Right, now I'd like you to put your finger on the time that is the same as saying 3:40 p.m. So hopefully you are pointing at 15:40 for the 388 aircraft on the SQ308 flight, because 3:40 is the same as 15:40 because you add on 12 hours. Right, last one. I would like you to point at the one that says 11:45. Which time says 11:45? So hopefully you are pointing at 22:45 for the BA12 flight. 22:45, so if I take away 12 hours, it would be 10:45, and 10:45 is the same as 11:45. Perfect. Right, we're now going to play our lesson. So I'm going to ask you a few simple questions about this timetable just so we know that we are confident with using it. So if we look at the flight SQ306, hopefully you can put your finger on that flight there. I want you to tell me which days it does not fly. So which days is that flight not happening? So this is a horizontal timetable, so you need to look horizontally across the screen. Which days does this flight not happen? Hopefully you are telling me Wednesday and Saturday, because that's when there is no aeroplane symbol in that day, which tells me on those days it's not happening. So it does fly on Monday, Tuesday, Thursday, Friday, Sunday, but it doesn't fly on Wednesday and Saturday. Right. Can you tell me how long is the flight from Singapore to London that leaves at 11:30? So 11:30 is the same as saying 23:30, and that flight takes 13 hours and 25 minutes. Right, next one then, and for this one you might need to look at the note at the bottom. If I caught the BA12 flight and I left on a Monday, what day and what time would I arrive? So hopefully you can tell me that if I left on Monday and I caught that flight, but actually because it's got that +1 next to it, that means that I land a day after departure. So if I leave on a Monday, I would land on a Tuesday. Perfect. And you might be thinking, but that's not 13 hours difference. Well, because of the time difference, it would be a little bit different. So it wouldn't show 13 hours. But that +1 means 1 day after departure. So we would land at 5:05 in the morning on Tuesday. Perfect. Okay, here is our discover problem. Now, you don't have these textbooks with you, so don't worry about trying to find these questions. So, when we look at this timetable, there's a couple of things straight away that I noticed that are different. So I want to pause the video and have a think about how is this timetable different to the one we've just seen. Well, for a start, the other timetable went across horizontally for each different flight. When I look at this one though, for one, we don't seem to be looking at flights, we are looking at buses. And secondly, rather than the times of the buses going horizontally, it's now going vertically down in a column. I can see that I've got different stops down the side, which again I didn't have on the other timetable either. And this time I've got bus A, bus B and bus C. So if you are going to catch the bus to secondary in September, or even just to go into town or something like that, this is the kind of timetable that you might see. So there's the questions first. How many buses go to Anderton Primary School? Well, there's bus A, bus B and bus C, so there are 3. How many stops does bus B make? Well, bus B, the same as A and C, makes 6 stops. It stops at every single one of those because there is a time for Nicholson Street, Clements Way, Hart Lane Shops, Mason Avenue, Marigold Crescent and Anderton Primary School. If any of those columns were left blank, that would mean it doesn't stop there. But this shows me that all 3 buses stop at every single place. Right, let's have a look at some questions then. So, we have a little girl called Emma, and Emma is going to breakfast club. The school bus picks her up from Clements Way at 25 to 8. That's our first bit of information. It picks her up at 25 to 8. So I want you to find now at Clements Way, 25 to 8, would she be on bus A, bus B or bus C? Second part of this question, what time does Emma arrive at school? So, if she got on the bus at 25 to 8, 25 to 8, as we know from Monday's lesson, is the same as 7:35 because it's 35 minutes past 7. And if you added 25 minutes, you would get to 8 o'clock. So 7:35, which means it's bus A. Bus A, if I go down the column, gets to Anderton Primary School at 8:05. Right. Second question. We've now got Max. Max gets on the bus at 7:57. What time would he get to school? So if Max gets on at 7:57, he gets on bus B from the Hart Lane Shops. So if I follow bus B down the column, he would get to school at 8:20. Right. Last question then. All the buses take the same time to get to school. What time would bus C arrive at school? Okay, and you can see that bus C's time for school, his arrival time, is actually blocked by Max's bag. There are loads of different ways that you could work this out. So I'm going to pause the video and have a go at some of the ways to see if you can work out what time would bus C get to Anderton Primary School. So, you're going to have to use the information from the other buses to work out the hidden time. If you know that bus A goes from Nicholson Street to Anderton Street, you can look at those times and work out how long it takes each bus to get to the school, because as it says in the question, we know they all take the same amount of time. So, bus A leaves at 7:15 and gets there at 8:05. So, if you look on the left where there is the number line. So, let's work out how long this bus takes then. Well, from 7:15 to 8 o'clock, we are adding on 45 minutes because that's 7:15. Another 45 minutes would take us to 8 o'clock. So that's 45 minutes, but then we need to get to 8:05, so we had another 5 minutes. So it would take 45 add 5, which would be 50. So each bus takes 50 minutes to get to school. And we can check that by looking at bus B. Well, bus B would be 7:30, add half an hour to get to 8 o'clock, and then add 20 minutes to get to 20 past 8. 30 add 20 would be 50. So we now need to look at bus C. Bus C starts at 7:45, and we need to add on 50 minutes. So you can see this on the clocks on the right. So we can add on 15 minutes to get us to 8 o'clock. And then how many minutes do we need to add? If we need to add 50 altogether, we've already added 15. So we add another 35. So this bus would get to school at 8:35. Now, personally, the way I would have done this is I would just have looked from Marigold Crescent to Anderton Primary School. I know from Marigold Crescent, it goes from 7:56, and add 4 minutes to get to 8 o'clock, and then another 5 minutes to get to 8:05. So I know from Marigold Crescent to Anderton Primary School, it only takes 9 minutes. And I can check that with bus B. There's 9 minutes between 11 minutes past 8 and 20 minutes past 8, because 11 add 9 is 20. So all I need to do is I need to add 9 minutes to bus C's Marigold Crescent time, with 8:26. 26 add 9 would be 35, so it would be 8:35. Okay, you could use any of the bits of information about the other buses to work this out. It doesn't matter which way you do it. Okay, time for the think together. So this time, is this a train timetable or a bus timetable? It's a train timetable. I know that because it says it at the top. That's why it's always important to read the information around timetables in a question so that you know what you're dealing with. So it's a train timetable. If I look at these then, at the top, it no longer says train A, train B, train C and train D. But hopefully you can see that we've got 4 trains and the times are running down the page. They're running vertically down the page in columns. So train A would start at Littleborough at 14:13 and get to Ashtown Central at 15:20. So, question A. Lexi gets on the 15:07 train at Birchfield. So, I want you to put your finger on 15:07 Birchfield. Make sure you found that right time. What time would she arrive in Ashtown Central? If you go down the column, what time would she arrive? 15:50. What's 15:50 the same as? 15:50 is the same as 3:50 or 10 to 4. Right, next one then. What about if Lexi got on the 15:13 train from Littleborough? What time would she get to Ashtown Parkway? Hopefully you're looking at this and thinking, but she wouldn't get to Ashtown Parkway. Okay, well done. I was trying to trick you. So this one has got a dash. If there's a dash in the column, that means that the train does not stop there. So the 15:13 train from Littleborough doesn't stop at Birchfield and doesn't stop at Ashtown Parkway. It goes straight through to Ashtown Central. So if she got on that one, she wouldn't be able to stop. She'd have to get off at Ashtown Central and then she'd have to get a train back to Ashtown Parkway. Okay, next question. Andy gets on the 14:13 train at Littleborough. So make sure you find that train. How long would it take him to get to Birchfield? Have a go. Okay, so if I'm looking at this timetable then, he gets on the 14:13 from Littleborough and he's going to Birchfield. So he's only doing one stop. So I need to know how long would this journey take? What's the difference between 14:13 and 14:37? Now, you could just do that sum in your head. If you can't, don't worry. The best method to use is a number line. And the jumps you take and the size of the jumps you take is completely up to you, and it's how confident you are with your mental math skills. Now, I've tried to break this down so that you can see everything that I've done. So we start at 14:13 and we want to get to 14:37 because that's where he gets off the train. So the easiest thing to do is to do this in nice manageable chunks. So what would you add to 13 to get it to the nearest multiple of 10? So I'm going to try and get to 14:20. And if you think about a clock, that's kind of So you could get to 14:15 because that's one of the numbers on a clock, or you can try and get to the next multiple of 10. It's completely up to you. You might even want to go as far as going to 1/2 if that's what you're comfortable with. It's what you are comfortable with in your mental maths. I'm going to go to the nearest multiple of 10, so I'm going to go to 1420. And to do that, I know 13 add 7 would get me to 1420. Right, but I want to get to 1437. So now I'm going to add 10 minutes to get to 1430. How many minutes left to get from 1430 to 1437? I'm going to add another 7 minutes. So I've added 7 minutes, add 10 minutes, add 7 minutes. So altogether I've added 24 minutes. So the journey would have taken 24 minutes. Now, if you start at 1413, if you add 24, you would get 1437. So you could have done that mentally, or you can use this number line method. Okay, and into our practice book. So we've got 2 questions and then we are done. So this is part of a railway timetable. Olivia arrives at Boston at 10 o'clock and catches the next train to Skegness. How long is she on the train for? Pause the video and have a go. So with this question then, Olivia arrives at Boston at 10 o'clock. So I look down, here's Boston. If she arrives at 10 o'clock, which train would she get on? Well, she wouldn't have arrived yet. She wouldn't have arrived yet. She wouldn't have arrived yet. Oh, she'd have arrived. So she'd arrived here in between 9:12 and 10:26. So she'd arrived here at 10 o'clock. So which train would she get then? Well, she'd get the 10:26 train. So that's what time she leaves Boston then. And she's trying to get to Skegness. So I'm going to go all the way down until I get to Skegness. So she would have got off at 11:06. So I'm going to work this out using a number line. So I start at 10:26. I'm going to add 4 minutes on to get to 10:30. Add 30 minutes on to get to 11 o'clock. Add 6 minutes on to get to 11:06. And I need to add these up. Well, 6 add 4 is 10. Add 30 is 40. So she'd be on the train for 40 minutes. Okay, last question for today then. It is 6:34. Mo is at Grantham and has just missed the train. He wants to get to Haven House. So this is a 2-part question here. Number 1, what time will he get to Haven House? And number 2, from the time he walks onto the platform at 6:34 to the time he gets off the train at Haven House, how long has his journey been? Okay, so he's at Grantham at 6:34. So that's the train he's just missed. And this is where he is now. So he wants to get to Haven House. So if he got on the 7:23, he wouldn't be able to get to Haven House because it doesn't stop there. So if he waits and gets on the 8:16, he won't be able to get to Haven House because it doesn't stop there. So he's going to have to wait until the 9:32 train, and he would get to Haven House at 10:56. So give yourself a mark if you put 10:56. So to work out how long it's going to take him then, we're going to draw a number line. So I've gone from 6:34, I've added 6 minutes to get to 6:40. Then I've added 20 minutes to get to 7 o'clock. And then I've done 3 hours, and a big jump here, 3 hours to get to 10 o'clock. And then to get to 10:56, I've added another 56 minutes. So to add all these up then, we've got 3 hours and 56 minutes. If we add those 6 minutes, we've now got 4 hours because we've gone over that 60 minutes. So we've got 3 hours, 56 add 6 would be 4 hours now and 2 minutes, and we need to add this 20 minutes, and now we've got 4 hours and 22 minutes. And this is why you've always got to be on time and not miss your train. He's had to wait 4 hours and 22 minutes to do that journey. Right, well done for today. You've worked really hard on that. So tomorrow and Friday we're going to be doing problem solving around time and timetables. See you later.